This is Roopa Prasad, Department Assistant Professor, Department of Computer Applications, MITS College. So today we are going to discuss about the topic called as classic encryption techniques. Okay. So it is a part of cryptography network security series. So in this one, we are going to discuss about substitution techniques. Then we are in the substitution techniques, we have the following techniques are there. Then we are going for the transposition technique. Then we discuss about the stream cipher as well as a block cipher. Okay. Actually, we all know that the cryptographic algorithms are of two types. One we call it as a symmetric, and the one is called as a asymmetric. So symmetric means what? Here we are using only one key for both encryption and the decryption process. Whereas in asymmetric, we are going to use a pair of keys. One key is used for the encryption, another key is used for the decryption. Sorry. Okay, so in the symmetric cryptography, we are going to use the encryption techniques. We are going to use for the encryption process, we are going to use the two basic building blocks are there. That means there are only two techniques that are used in the symmetric cryptography. One we call it as a substitution and the one is called as a transposition. So these two techniques are called as a classic encryption techniques, or we can also call it as a traditional encryption techniques also. So these two techniques are the base for the symmetric encryption algorithms. So in the symmetric encryption algorithms, we are mainly focusing on the substitution as well as the transposition. That's what we are going to discuss today. Okay, so the substitution means what? In the name itself, we can say substitute. We are going to substitute one character with the another character. That's what it said. A substitution technique is one in which the letters of the plain text are replaced by the letters or by numbers or symbols. Okay, so the plain text will be replaced. The plain letter of the plain text will be replaced by the another letter or symbol of a cipher text. That we call it as substitution technique. So in this substitute that we call it as a substitution technique. Whereas coming to the transposition, what this transposition means, in the name itself we can say we are going to transpose the bits. That means we are going to change the position of the plain text. We are not going to substitute any new character. We are going to just change the position of this plain text. That is called as a transposition. Okay. So if the plain text is viewed as a sequence of bits, then substitution involves replacing the plain text bit patterns with ciphertext bit patterns. That we call it a substitution. Substituting a character with the other character. Okay, plain text character will be replaced with another character that becomes a ciphertext. That we call it as substitution. Then transposition means changing the positions of the plain text. Okay, so these are the two basic building blocks. So we call this as a basic building blocks of all symmetric encryption process. So in the symmetric encryption, we are going to depend more mainly on these two techniques. One is called as substitution and the one is called as a transposition. Then we discuss what are the some substitution techniques are there. There are some substitution techniques are there. So these are the substitution techniques that we are going to discuss. So the first one is called as scissor cipher, or we can call it as scissor substitution technique. Then other one is called as a mono alphabetic cipher. Then third one is plain fade cipher, and fourth one is hill cipher, and fifth one is polyalphabetic cipher, and sixth one is one-time bind. These are some of the substitution techniques that we are going to discuss today. Okay. So first we go for the first substitution technique that we call it as a Caesar cipher. Okay, this is a simpler substitution technique that we are going to use. Then this technique has been used by Julius Caesar. Okay, so what this substitution technique is going to do means in this substitution technique we are going to replace each letter with the letter standing three places further down the alphabet, further down the letter that we have chosen. Okay, that means what? For example, in the plain text, there is a letter called as A. Okay, so A will be replaced by D. That means what? We are going to leave two letters after A and then we are going for the next letter. See this example, by seeing this example, we can come to know. So meet, the plain text is meet me after the toga party. So plain text letters are what? The plain text letters are there, M, E, E, T. So M will be replaced by P. M will be replaced by P. That means what? After M, two letters further, three letters further down. That is three places after M. In the third position we have P. So M, N, O, then we have P. Okay. So M is replaced with P. That is M is substituted with P. Like that, E is substituted by H, E is substituted by H, T is substituted by W, like that we are going to substitute. That we call it as a substitution technique. That one of the technique is called as a Caesar cipher. So in this Caesar cipher, what we are going to do, the formula which we are going to use is the letter standing three places further down the alphabet. That we call it as a Caesar cipher technique. And this technique has been used by a king called as a Julius Caesar. Okay, and here one more thing we have to consider. The thing is the alphabet is wrapped around so that the letter following Z is A. That means after Z. Okay, for example, in the plain text we have a letter called as a Z. Okay, letter Z. After that Z we have to go two further. That is, we have to leave A, B, then we have to take C. That means Z is replaced with C. That is substituted by C. Like that we have to take. That is the simplest technique, simplest substitution technique, that we call it as a Caesar cipher. Okay, and this notationally can be described like this. Then it can be expressed like this. So this is a ciphertext. This is a notation what we are going to use. C is a ciphertext and P is the plain text. So E is an encryption algorithm. We are going to apply the encryption algorithm on the P. And what is the key we are using? 3 is a key. That is P plus 3. So how we are getting the ciphertext? By using plain text letter equivalent plus 3 mod 26. So why you are going to use mod 26 means the alphabet range is 26 only. So whenever we get the ciphertext, it should be in the alphabets only. For that purpose we are going to use mod 26. So what happens, this is a form, this is a notation we are going to use. We are going to get the ciphertext by applying the encryption algorithm by using the key on the plain text called as P. Okay, so where K takes a value ranges from 1 to 25. So, and this is a decryption algorithm. As we have already discussed, decryption is the opposite to encryption. It is the inverse of encryption. So here we are going to use addition. Here we are going to use a subtraction. So here we are going to get the ciphertext, and here we are going to get the plain text from the ciphertext. And what algorithm we are going to use? We are going to use the decryption algorithm. So this is the simplest substitution technique, one of the substitution technique, that we call it as a Caesar cipher. Okay, then we go for another technique that is called as a mono alphabetic cipher, mono alphabetic substitution technique, or we can call it as a mono alphabetic cipher. So here what happens, each letter in the plain text is replaced by a different letter or symbol in the ciphertext according to the fixed substitution. This you have to note. Okay, in Caesar, it is similar to Caesar cipher. But what happens in Caesar cipher, we are going to use a simple, same formula, that is P plus 3. That is after three letters, after leaving the two letters only, we are substituting the third letter. Okay, but here how the substitution is done, based on the substitution, based on the rather than simple shift, we are going to take the permutation, random permutation. For example, for one message we can go for plus 3, for some messages we can go for plus 4, like that we can do. Okay, before or after we can do. Okay, so here what happens, so simple, this one is example. So A is substituted with D, B is substituted with E, C is substituted with F, like that we are going to substitute. We take one method here, we take one substitution here. By following this only, we are going to substitute the plain text and we are going to make it as a ciphertext. Okay, so this is called as a mono alphabetic. So in the name itself, a mono alphabetic. That means one letter is replaced by one other letter. One letter is replaced, is substituted by another letter or another alphabet or another symbol, that we call it as a mono alphabetic cipher. Okay, then we go for the next one, that is called as a play cipher. Okay, play cipher is also one substitution technique, and what it is a polygraphic substitution. Polygraphic means what, we will tell in the example. So this has been invented by Charles Wheatstone in 1854, but named, why this name means, because a person called as a Lord Playfair has promoted its use, okay, during Crimean War. For that purpose, this substitution technique has been named after him, like Playfair. That is a Playfair cipher. So what this cipher is going to do, what is going to happen in the substitution technique means, here we are going to use 5 by 5 grid of letters. Okay, so this is a 5 by 5 grid, that is 5 rows and 5 columns. So in this 5 rows and 5 columns, we have to arrange all the alphabets. How we are going to arrange means I will tell you. We are going to take a keyword. Okay, we can take any key we can take, that we are going to take the keyword. Okay, just I will show you in the example. We just go for the example so that you can clearly understand. So this is a 5 by 5 grid. Okay, here we have taken the keyword as key as monarchy, MONARCHY. Okay, this letters we have to write in the cells. Okay, 5 by 5 grid, that is in the matrix, we have to fill the letters of the keyword. Okay, then whatever the remaining letters, that has to be filled in the remaining cells. Okay, actually how many cells will be there? 5 by 5 means we have 25 cells, but we have 26 alphabets. So what we are going to do means, for in one cell we are going to accommodate I or J. Okay, I and J will be accommodated in only one cell. For example, so what is the keyword here? Monarchy is a keyword. Okay, so A is already there, so we are going to insert B. Okay, then C will be there, then we are going to place D, E, F, G, H is there. So G, H, I, J will be in the one cell only. K, L, M is there, N is there, O is there, P, Q, R is there, S, T, U, V, W, X, Y is there, so Z. Okay, like that we are going to fill up the cells. Fill up the cells of 5 by 5 grid. Is it clear? So what we are going to do, we have to take one keyword. Okay, first the keyword has to be placed in the cells. Okay, then whatever the leftover alphabets has to be placed in the remaining cells. What is the condition here? You are going to place I and J in the same cell. Same cell, we are going to accommodate I and J. Why? Because means there are 25 cells are there, but alphabets are 26. So we are going to accommodate I or J. For example, if I is there in the keyword, then we omit J also. Okay, we omit J also. If J is in the keyword, we omit I also. So I and J should be accommodated in one cell. Then how you have to encrypt? How you have to encrypt means, so what we said, this is polygraphic. Polygraphic means we are going to take more than one letter at a time and we are going to replace. In the previous example, what we have said, monoalphabetic and Caesar cipher, a single letter is replaced by a single letter, is substituted by a single letter. But here we are going to consider a pair of letters, that we call it as a polygraphic, more than one letter. Okay, so for example, if you want to encode a plain text, that is called as a balloon. Balloon is a plain text. Supposing that that is example, we have to encode the encrypt balloon. Okay, so here how you have to do means, you have to divide this word in a pair of letters. In a pair of letters. That means BALL OON. Okay. Now what happens? What we have to consider means, if there is a sequence of letters like this, L or L, those are the same letters. So we have to part another letter in between this LL. Okay. So what you are going to take? You are going to take a letter X and we are going to place in between LL. So that what I'm going to say means that two letters will not be same. Okay. When we divide into pairs now, then the two letters will not be of same. Okay. So what we are going to say, BA is one pair, LL should not be one pair, because LL same letters. So we are going to part X in between. So LX is one pair, LO is another pair, ON is another pair. Like that we have to divide into pairs. For example, now we have supposing that BALAOON is there, something is there. So that means 1, 2, 3, 4, 5, 6, 7 letters are there. So we have to divide into pairs. 7 letters cannot be divided into pairs. 2 to letter 6, there is only one letter, there we can add another letter, say X we can add. Okay, like that we have to divide into pairs. Is it clear? We have to divide the word into, we have to partition the word into pair of letters. Then we see how we are going to encrypt. Okay, there are three rules are there. Suppose this pair, for example, if you want to, I will show you in here. Suppose if you want to encrypt AR. Okay, suppose there are three rules. First we discuss the three rules. if the pair of letters are in the same row, if the pair of letters are in the same row, then we have to take the rightmost letter. Okay, right letter to this letter. Okay, what I will show you in the example. Suppose you have to encrypt AR. You have to encrypt AR, CAR. A is here, R is here. That means two letters are lying in the same row. Okay, then what you have to take, A is substituted by the right letter. That is, A is substituted by R. Okay, and R is substituted by M. We have to view this as a circular. Okay, is it clear? So, if the letters are in the same row, then what you have to take? You have to take the next right letter. Okay, then we have to substitute the letter with the next right letter. Okay, now see, we have to encrypt AR. We have to encrypt AR. So AR in the same row. So in place of A, we are substituting the right letter, that is R. In place of R, we are substituting the right letter, that is M. We have to view this in a circular fashion. So we are going to get RM. So AR is encrypted as RM. Is it clear? So I take one more example. Suppose the pair of letters are HB. Okay, so HB, you have to encrypt HB. So in place of H, you are going to substitute Y. In place of B, you are going to substitute D. That is the rule. Okay, if the letters lie in the same row, then you have to take the right letter. Okay, that's what it is said. Okay, if two plain text letters that fall in the same row of the matrix are each replaced by the letter to the right, with the first element of the row circularly following the last. That is the rule. Okay, next we go for the another rule. That is, if no plain text letters are in the same column. Suppose if you want to encrypt MU, okay, M is here, U is here. That means the two letters lie in the same column. The two letters lie in the same column. Then you have to take the beneath letter. Okay. So, for example, M, U. You have to encrypt M and U. So, below this M, we have the letter C. So, in place of M, we are substituting C. In place of U, we are substituting M. We have to view this as circular fashion. Okay. You have to substitute MU. You have to encrypt MU. So in place of M, we are substituting C. In place of U, we are substituting M. Okay, is it clear? That is a way of doing encryption if the plain text letters fall in the same column. Okay. Now, suppose if they are not in the same row or not in the same column, that means they are in the different row and different column. Then what you have to do means, for example, you have to encrypt H. Yes. So where is H? H is in the second row, and H is in S is in the fourth row. Okay, so second row, second column. Now this one is fourth row and fourth column. So how you have to do means, so H is substituted by B. Okay, the intersection point where H is H and S. These are the pairs. So H is interacting with S at B. Okay, so we have to substitute with B, and S is substituted by P. Is it clear? Like the diagonal we have to take. Okay, that is a third row. Okay, so H is substituted by B and S is substituted by P. For example, E. We see here E, and where is A? A is here. You have to encrypt the plain text, the page, that is E and G. So E is substituted by I or J. That depends upon the who is going to encrypt the message. So he can opt for I, because I and J lies in the same cell. We can go for I or we can go for J. So E is substituted by I, A is substituted by M. That what is said. EA becomes IM or JM. That becomes on the encrypted wishes. Clear? That we call it as a play phase substitution technique. So play phase substitution technique. In this technique, we are going to take a 5 by 5 grid where we are going to arrange the keyword and the remaining alphabets. Then how we are going to substitute based on the three rules. If the pair of letters fall in the same row, then we have to take the right letter. If the pair of letters fall in the same column, then we have to take the beneath letter. If the pair of letters are not in the same row and some same column, then you have to take the at intersection points. Suppose you have to encrypt M, yes. So M is substituted by A and S is substituted by L. That is a criteria we are going to use for the play phase substitution technique. Next we go for next one, that is called as a Hill cipher. This is also one of the substitution technique, and this is also a polygraphic substitution technique. That means what? We are going to take more than one letter at a time in order to encrypt. Okay, and this substitution technique has been invented by Lester S. Hill in 1929. Okay, so what this Hill cipher technique is going to use means it is going to make use of linear algebra and modular arithmetic for the encryption process and decryption process. Here we are going to make use of a key, and this key is a square matrix, and generally this is of 2 by 2 or 3 by 3. Okay, suppose the key is 2 by 2, then we are going to encrypt two letters at a time. If we are taking 3 by 3, then we are going to encrypt three letters at a time. That's why we are saying polygraphic substitution technique. We are going to substitute two letters. If we are taking 2 by 2 matrix, then we are going to substitute two letters at a time. If we are taking the key as 3 by 3, then we are substituting three letters at a time. That's what we are saying. This is a polygraphic substitution technique. Okay, and the key matrix must be invertible modulo of size of the alphabet 26. Okay, so next we continue this one. Okay, we continue this one with an example. Suppose m equal to 3. That means what? We are going to take 3 by 3 matrix. So the key size is 3, 3 by 3. So in 3 by 3, we have K11, K2, K11, K12, K13, K21, K22, K23, K31, K32, and K33. So how you are going to take? Take means you have to, we are going to substitute 3 plain text letters with 3 ciphertext letters. So how the ciphertext can be assumed? C1 equal to K11 into P1 plus K21 into P2 plus matrix multiplication you have to perform. Okay, mod 26. Okay, like that we can get the ciphertext C1, C2 and C3. Okay, now see, this can be represented like this. Now, okay, so this is a key, 3 by 3 key. So it is 3 by 3. So we are going to substitute 3 plain text characters with 3 ciphertext. So how we are going to take the formula which we are going to, the notation which we are going to use is PK mod 26. P into this matrix mod 26. So we are going to see, for example, this is a plain text, pay more money. Okay, so this should be arranged in the form of a matrix. Okay, so P, we have to take the numerical equivalent of P, that is numerical equivalent of P, that is 15, A is 0 and Y is 24. Then what you have to do, you have to multiply with K. K. When we multiply with K, we are going to get this one, and this we call it as a ciphertext. This we call it as ciphertext 17, 17, 11. That is not, that is equivalent to RR here. Like that, we are going to complete the entire plain text into ciphertext. We are substituting this plain text characters into ciphertext characters. Okay, that we call it as a Hill cipher, which is going to make use of algebra, linear algebra. Okay, and the notation will be like this. Okay, ciphertext can be achieved by encrypting the plain text by using the key called as key. And what is the key we are using? The formula we are using, PK mod 26, and inverse will be the decryption process. And another substitution technique is polyalphabetic ciphers. That means what? More than one, we are going to substitute one character with more than one characters. That I will show you an example. So it is a simple. It is another way to improve the monoalphabetic technique. So what you are going to do means here. See, okay. So this is one of the simplest example of the polyalphabetic cipher, that is Wegener cipher. So in this Wegener cipher, what you are going to do, it's going to take the Caesar cipher only. So how you are going to do means, so this is a, we are going to take a key. Okay, so this we call it as a key. So defective is a key. Type 2 is a key. That key has to be repeated until the length of the plain text. So this is a plain text. Okay, we are discovered, save yourself. That is one plain text message is there. So this sub 2 is the key. So this by this length we have to repeat this key. We have to repeat this key. So and what happens? So W will be substituted. We have to take the numerical equivalent. W will be substituted. D. What is the number for D? Numerical equivalent of D is 4. Okay. That is W is substituted 4 letters after. Okay. Like that we are going to substitute. We are going to substitute. So W uh, W is substituted by Z, E is substituted by I, A is substituted by C. Like that we have to substitute. So A, B, C. We are going to substitute by C. Okay, like that we are going to substitute. So that we are going to get different letters. For example, here E is there. For E we have substituted I, but for here E we are substituted with T. Why? Because the key is P. The key is P. So we are going to substitute with T. Like that, this we call it as a polyalphabet. Hope you understood the difference. Okay, monoalphabetic means the same letter will be substituted. The same letter will be substituted. For example, once E is substituted by I, then whenever we have E, that is substituted by I only. But what happens here? E is substituted with I, and here E is substituted with D. Why? Because means by making use of the key. Okay, that is called as a polyalphabetic cipher. And next, another substitution technique that we call it as a one-time part. Okay, by the name itself, we can say it is clear one time part. That means the key will be used for only one time. The key will be used for only one time. Okay, so this technique has been given by this person. Okay, Joseph Mormin. So he proposed this one. He proposed this one by improving the Varnam cipher. That is a polyalphabetic cipher. So he suggested a random key that is as long as a message. So in the previous substitution technique, what we have taken, the key will be repeated as the length of the length of the plain text. Here what happens, we are going to take the key as long as a message. Okay, if the message is of 24 bits, the key should be of 24 bits only. And we are going to take the random key. That means for single message you are going to take one key only. After that message a new key will be formed. Okay, that is a technique we are going to use in one part a one time part substitution technique. Okay, so these are the substitution techniques what we have discussed, that is Caesar cipher, mono alphabetic, then coming to Playfair, Hill cipher, then we have discussed polyalphabetic as well as a one time part. Then we come for the transposition techniques. So what is a transposition technique? That means what? Here we are not going to substitute any other character, but we are going to change the position of the elements. The elements of the plain text are rearranged. Okay. And one of the technique here we are going to use is that is rail fins. Okay. So what happens here? The message is written in this form. Okay, as a sequence of diagonals. For example, meet me after Toga party is a message. So how we are going to write in the diagonal line? Of the depth 2. That means M E E E T M E A F T E R T H E T O G P A R G A P R T y. Like that we are going to write in the diagonal fashion. Okay, after that we are going to just combine the message. So this we call it as ciphertext. Here we have not substituted any other character, just we are going to replace the characters. We are going to change the position of the characters. So M is a first position, E is a second position, so M E will be same. Then what is the next position? E is the next position, but we have changed the position with M. Like that we are going to change the positions. Okay, so this we call it as a transposition technique, and one of the technique is rail fins. Okay, then we go for another one, that is, so in order to make this so complex, what you are going to take means you are going to arrange the plain text in the form of a matrix. Okay, and we are going to take one key. Okay, so for example, this is a message: attack postponed until 2 a.m. Okay, remaining has to be filled with the XYZ, that we call it as padding. Okay, and we have taken the key. That is, what is the key? 4312567. That means the first this column should be given. Okay, so we are giving the ciphertext as TTNAA. Okay, then we have to go for the second call. This one. Okay, second position is this column. Third position is this column. Fourth one is this column. Fifth one this column. Sixth one this column. And seventh one this column. Like that, we are going to arrange. Okay, that is, in order to make that rail fence complex, we are going to take this form also. Okay, here you have to observe here. We have not substituted anything. We have just changed the positions of the plain text. For that purpose, we are calling this as a transposition. And next one more thing. Okay, so depending on the how we are going to perform the encryption, we have two types of ciphers are there. One we call it as a stream cipher, another one is called as a block cipher. So in the stream cipher, what happens, the data stream is considered as a stream of bits. Okay, so on this is a plain text, we are going to apply the encryption algorithm on every bit or byte. That is called as a stream cipher. That is called as a stream cipher by using the key. Encryption is performed by using the key only. So that is applied on a bit by bit or byte by byte. That we call it as a stream cipher. Okay, so stream cipher is one that encrypts a digital data stream one bit or one byte at a time. That is called as a stream cipher. Okay, and coming to next one, that is called as a block cipher. So in this block cipher means a block cipher, what happens? We are going to consider the block of bits as a plain text. Block of bits as a plain text, and encryption and decryption algorithm is performed on this block of bits. Okay, that we call it as a block cipher. Is it clear? So stream cipher, or we can call it as a block cipher, based on how we are going to perform the encryption. That we the ciphers are divided into stream cipher and block cipher. In stream cipher, what happens? The encryption and decryption algorithm is performed bit by bit or byte by bit. So in block cipher, what happens? We are going to consider the plain text as a block of bits. On the block of bits, we are going to apply the encryption algorithm or decryption algorithm. So generally, the block size will be of 64 or 128 bits. Okay, so this is called as a block cipher. And DES algorithm, that is called as a data encryption standard. That is a block cipher algorithm. There is a symmetric block cipher. That means what? It comes under the symmetric cryptographic algorithm, and we are applying in the block of plain text, so we call it as a block cipher. Okay, and generally the block size will be 64 or 128. But generally, most of the common size of a block is 64 or 128. That's all about the classic encryption techniques. So this is also called as a traditional encryption techniques. So these techniques are based for all the symmetric encryption algorithms. Hope you understand. And this material has been prepared by using these references. And if you have any feedback, you can contact me. Okay, thank you.